Did you know that your compass doesn't actually point to the geographic North Pole? Right now, it's being pulled toward a mysterious place that never stands still, a point that drifts across the top of the world, dragging every compass needle on Earth along with it. This is one of the most fascinating and least understood features of our planet, the magnetic North Pole. Imagine the Earth as a giant invisible magnet. But here's the incredible part, that magnet isn't fixed, it moves. It changes shape, and from time to time in Earth's history it even flips completely around. Over the last 150 years, the magnetic North Pole has traveled more than twice as Andalusum, and right now, in 2025, it's speeding towards Siberia at nearly 55 kilometers per year. Let's start with the basics. The geographic North Pole is simply the point where Earth's axis of rotation meets the surface. But the magnetic North Pole is very different. It's the spot where Earth's magnetic field lines plunge straight downward. A compass placed exactly at that point would spin aimlessly, because the pole comes from directly below. As of 2025, the magnetic North Pole sits around 86.5 north and 1629 west in the Arctic Ocean north of Canada, but it's already more than 500 kilometers away from the true North Pole and heading east towards Siberia. So why does this magnetic field exist? The answer lies 2,800 kilometers beneath your feet, deep in Earth's molten outer core. Picture a vast ocean of liquid iron swirling at over 4,000 degrees Celsius hotter than the surface of Thesan. As this conducting metal moves, it generates electric currents, which in turn create magnetic fields. Those magnetic fields feed back and sustain the current, forming a self-powered engine called the geodynamo. That invisible dynamo has shielded life on Earth for billions of years, deflecting solar radiation and preventing our atmosphere from being stripped away. But because that liquid iron flow is constantly changing, the magnetic field above is restless too. The currents of molten metal twist and churn, and as they do, the magnetic poles wander. The history of that wandering is extraordinary. The first European to find the magnetic North Pole was the explorer James Clark Ross in 1831. He discovered it on the Boothia Peninsula in northern Canada. For more than a century, the pole drifted slowly, just a few kilometers per year. Then in the 1990s, everything accelerated. The pole's motion jumped from 15 kilometers per year to over 55. What happened? Deep below Canada, one magnetic region began to weaken, while another beneath Siberia strengthened. It's like an underground magnetic tugo and Siberia is winning. The pole has now crossed the 180-degree meridian and could reach northern Siberia within 2 decades, making it one of the fastest shifts in recorded history. You might wonder, does this really matter? Absolutely. The moving pole affects modern life more than most people realize. Every navigation system from smartphone GPS to aircraft autopilots must constantly adjust to keep up with the changing magnetic orientation. Even airports have to rename their runways as the magnetic bearings drift. For instance, Tampa International in Florida had to change its markings from 36L18 Arto 1L19 Arto match the new magnetic headings. Behind each update lies reprogramming new maps and revised flight procedures. And that's not all. The rapid motion of the pole might signal the early stages of a magnetic reversal when the north and south magnetic poles swap places entirely. Geological evidence shows this has happened hundreds of times in Earth's history, the last one roughly 780,000 years ago. During a reversal, the magnetic field weakens for centuries, exposing the Earth to more solar radiation. To monitor these changes, scientists have built a global network of observatories and satellites that track the magnetic field 24 hours a day. In effect, a stethoscope listening to the planet's magnetic heartbeat. The European Space Agency swarm satellites are especially vital. Flying in formation, they measure variations as tiny as 1 nanotesla, so sensitive they can detect the magnetic field of a common battery from kilometers away. All this data feeds into the World Magnetic Mole, the global standard used by every navigation system, including the one inside your phone. Normally, it's updated every 5 years, But the pole's recent acceleration forced scientists to issue an emergency update in 2019 because it had drifted faster than expected. The magnetic North Pole isn't the only magnetic mystery we face. In the South Atlantic, there's a huge weak zone known as the South Atlantic Anomaly, where satellites are bombarded by more radiation than normal and sometimes glitch or shut down. Globally, Earth's entire field is weakening at roughly 5% per century. It sounds ominous, but on geological timescales, such fluctuations are normal. In fact, local magnetic anomalies are common too. In parts of Brazil, Canada, and Australia, concentrations of magnetic minerals can send a compass spinning south or in random directions. When you realize this, a simple compass becomes more than a tiny needle. It's a direct line to the living, breathing core of our planet. Every twitch of that needle echoes fluid currents thousands of kilometers below your feet. From the Arctic explorers of the 19th century to the satellites orbiting above us today, humanity has followed this moving pole with fascination. And today, as it races toward Siberia faster than ever before, one thing is clear: the Earth beneath us is not static. It's alive, dynamic, and still full of mystery. So the next time you open your phone to navigate or glance at a compass, remember you're connecting to one of the planet's deepest and most mysterious forces. The magnetic field that shields our world is shifting right now, shaping our technology, our navigation, and perhaps even our future. If this story intrigued you, hit like, subscribe, and share it with someone who still thinks north is a fixed direction. And tell me in the comments, did you know the magnetic pole was moving so fast? Would you like a deeper dive into Earth's potential magnetic reversals? Because every twist of that invisible field is a reminder. The Earth isn't just where we live, it's an engine, a shield, and a mystery still writing its story beneath our feet.